so problem number 1 here, we start off with something that is given to us. We're given a graph, and the graph is a parabola. It looks like a happy face here. So we just learned about parabolas and graphing them. It looks like a happy face with a vertex at 0, 0, right? Here they asked us to translate it to y is equal to x squared minus 3. So one way of doing it is like what you did in a previous module, which is y equals x squared minus 3, using the forms that we know how to use. We plot it in, we put 2 points to the left of the vertex, 2 points to the right of the vertex, and we draw it in, right? So that's a long way of doing it. So I'll say long way of doing it is to plot points, right? Plot points, find vertex, etc., right? Just like how we did it in the previous section, right? So that's a long way of doing it. Now we find a shortcut. Sure. So the shortcut that we're doing is that since we see it x squared minus 3, we see that its root form is y equals to x squared. That's something that we already know looks just like a happy face and it has a 0, 0 vertex. So if we're given that, all I need to do is subtract 3 from it. So if I subtract 3 from it, what's changing? Is it the x value that's changing, or is the y value that's changing if I subtract 3? For example, if I plug in 0, 0, right, x, y, or if I plug in 0, right? So in the function y is equal to x squared, in the normal function, if I plug in 0 into this, I get 0, right? If I plug 0 in for x squared, I get 0, right? If I plug 1 into this original function for x, what do I get for y? 1. And let me just do one more. If I plug 2 into this function, what do I get for y? Not 2, but 4, right? 2 squared is 4, right? And then I could plot it in, I could 0, 0, 1, 1, 2, 4, etc., right? Now, however, for the equation y is equal to x squared minus 3, this is the one that we're interested in. If I plug in the number 0 into this equation, what's 0 squared minus 3? Negative 3, right? So here, in my new graph, I have 0, negative 3. So notice that 0, the new function, I went how many steps down? 3 steps down, right? So here, I noticed that I went down 3 steps. So say even at the point 1, in my original equation, the y value is 1, but now in my new equation, y equals to x squared minus 3, if I plug 1 in here, what does my answer become? Negative 2, right? So therefore, 1, negative 2, I'm right there. So instead of doing this on and on forever with a bunch of points, one of the things that we could realize as a shortcut is that every single point in my original function is shifted down how many steps? 3 steps. So everything is shifted down 3 steps. So here I go, 1, 2, 3. Everything is shifted down 3 steps. 1, 2, 3. Here, 1, 2, 3. So on your ALEKS, instead of having to plot points or do all that work, I could just notice that, oh, okay, this is exactly the same. The roots, you could say the root graph is this, and all I'm doing is I'm shifting everything down 3 points. So the y value changes by shifting it down 3 points. So here I could graph it, and it looks like it's the exact same shape as its root function, but just shifted down 3 steps. Does that make sense? So the shape is exactly the same. The only thing that changed is that I shifted down 3 points. And that's the shortcut of doing this problem. Same story here with number 2. Here it gives me a function, and now there's no more graph, right? So now we're not looking at a graph, but it tells me that if this graph, whatever it looks like, right? I'm going to know that this graph is going to look like a sad face, right? Because it's a negative. I know it's going to look like a sad face somewhere along the graph. if the graph is translated, meaning shifted vertically upward by 9 units, so notice here, this was shifted down 3 units because it's a -3. If something is shifted up 9 units, what do you think I need to do to this equation to shift it up 9 units? I need to add 9, right? So since I'm adding it vertically, the y value is the one that's being affected. So I'm going to add 9 to this to get the new graph. That's exact same shape, it's just shifted up. So here, this graph becomes h. So I find the expression for h. So I'm going to say h of x is equal to negative x squared minus 8, the original function, plus 9, because we're adding 9 to the y value, right?
Would you be able to shorten it and just put negative x2 minus 1?
Great job, right? Not a -1, but plus 1, right? So yes, so that's exactly what you want to do. So you want to start with the original, and then you want to simplify it. So this would be the original equation, right? The new equation, h of x. So whenever you want to shift something up or down, you're going to add to the y value, right? So you're going to add to the function. If you want to go up, if you want to go down, you want to subtract from the function. Does that make sense? So now the question is, well, what happens if you want to move it left to right? So when you move it left to right, instead of adding or subtracting from the y value, guess what you're going to be doing? You're going to add or subtract from the x value. So let's look at the next page. So here in question number 3, here's the graph of f, which is in blue. F is the blue one. So so here's f, thank you. So f is the blue one. F in blue is translated, meaning that it's shifted a whole number of units, horizontal and vertical, to obtain the h function, which is in red. So I'll just put that in pink right here, the h function. So notice that the f and the h are exactly the same shape. Do you guys agree? They're exactly the same shape. So the graph is going to be, so the function is going to be exactly the same, except there's going to be a movement, a shift going left and right, or up and down. So there's a shift, horizontal and vertical. So we just learned how to shift things vertically. So when you shift things vertically, if you go up, what do? Add, right? So think, if you go up, you want to add. If you go down, you want to subtract, right? So here, the f function is defined as f of x is equal to the square root of x, right? So that's my root function. I just call this the root function. Root meaning like the root, right? The one that we're starting off with. So now we want to shift it, and they're asking us write down the expression for h of x. So the question is, what is h of x, right? So instead of trying to figure out what this equation is, I could start with the root that's given, and I could shift it. So to go from f to h, let's start off with the vertical movement. How many units did it have to move up to get to h? 3, okay. So we went from here to here, so we went up 3. So if we go up, we're going to add 3, right? So to go from here to here, I'm going to say h of x is equal to the square root of x, and then I'm going to add 3, because this 3 will make me move up 3 units. Is everyone okay with that? So if this graph was like right here, then I'm done. But it not only moved up, it also moved to the right. How many units did it move to the right? 2 units to the right. So if it moved 2 units to the right, we're going to change this x value. Here's the x value. This x value is no longer going to be x. And this is where it's going to be counterintuitive. You would think you would add 2 because you're moving to the right. But with the x value, it's the other sign. So it's going to be, you're going to subtract 2. So if you move 2 to the right, you're going to do subtraction instead. So this is where it is a little bit counterintuitive. So this x here now will become square root of x minus 2. That value x becomes x minus 2. And then you still have your plus 3. And that becomes your final answer. When we shift the graph, what changes, right? So here's just a summary. And the summary is this. If you move up, vertically up, then you add units to the y value, right? If you move down, then you subtract units. However, if you move to the right, you're going to subtract units to the x value. And then if you move to the left, you add units to the x value.